Differentiate your Cartesian coordinate system with the circular cylindrical coordinate system. It's mainly based on the varying factors are x, y, z in the Cartesian coordinate system. In terms of your circular cylindrical or cylindrical coordinate system, it is of rho pi z. Then this is our cylindrical coordinate system. Already we taken how it's going to be, and we learned what is rho. It is of a radius, and pi is the azimuthal angle, and z is same as z what we learned in our coordinate system, Cartesian coordinate system. And what are the ranges for rho? It is ranges from 0 to infinity. For pi 0 to 2 pi, and for z it is from minus infinity to plus infinity. Then how to represent a vector for cylindrical coordinate system? A rho, a pi and az, or else a rho of unit vector a rho plus pi with a unit vector a pi plus az with a unit vector az. This is the representation in terms of vector. Then we already come across about our unit vectors. If it is of the same, it will be 1. When it is of different factors, then it will be 0 for the dot product. For the cross product, arrow cross with a pi, you are getting as az, which is not there in the unit vector, that you will be getting the as a resultant. That's what about your cross product. So things we learned about for our cylindrical coordinate system. Then what is the relationship between our Cartesian coordinate system and also the cylindrical coordinate system? Here the relationship is going to be, this is very important in the exam. This question will be asking for 6 marks, or else for 4 marks also sometimes. Within 6 to 5, 4 to 6, this question will be asking. For from xyz to rho pi z, it's going to be, the rho is going to be equals to square root of x square plus y square. We are not going to derive how you will be getting, but the direct equations you have to remember this. Then for pi, in terms of our Cartesian coordinate system, that is going to be tan inverse of y by x. It is a magnitude part. Then about is in terms of angle, and z is going to be equals to sz only. In terms of our rho pi z to the Cartesian coordinate system, that is x is going to be rho cos pi, y is going to be rho sin pi, then z is going to be z only. Take this as equation 1. You have to remember these equations. Equation represents the transformation of a point from Cartesian coordinate system xyz to cylindrical, that is rho pi z. Then again this is terms. Then second equation is going to be rho pi z to the xyz. Here is the relationship between xyz and rho pi z. Observe here. This is our x, y, z coordinate system. This is our Cartesian coordinate system. A point vector here is going to be taken here. That is taken as p xyz, or else it's going to be equals to p in terms of Cartesian, or else in terms of a cylindrical coordinate system. This is going to be a pi. For this, y is going to be equals to rho radius into sin pi. Then x is going to be equals to rho cos pi of this distance. You can measure of or else you can write as sin pi is going to be equals to opposite, this whole distance will be y, so that the adjacent is going to be x. Same thing, cos pi is going to be x divided by rho. You can write anyway, but just remember here y is going to be rho sin pi and x is going to be rho cos pi. Then in terms of a unit vector relationship between for our Cartesian and also for the cylindrical coordinate system, rho pi z is going to be here for unit vector transformation for the component of ax bar. Unit vector ax is going to be like this. Our here what is done, just it is extended Observe here, it is just extended and it is taken in terms of your a pi, the direction. This is your angle pi and this is your 90 degree at a point and this is your b point, and this length is going to be minus sine pi a pi. This is your cos pi a rho pi a rho, and this the direction where it is moving, it is of our angle direction, that is of unit vector to the unit vector a pi. Then in terms of it is for the ax, for ay it's going to be, observe here, this is our pi angle, this will be 90, this is whole 90 minus pi, this is the angle. Then here it is of 90 degree. Again it is all the unit vectors are in a perpendicular to each other. That's what we already learned about how it is going to be. And this length is going to be from O to C is of my sine pi of unit vector a rho. This is in terms of a rho is moving. Then this for C to D it is of cos pi a pi. This is our unit vector a pi direction. This is for our ay direction. Then from the based on the graph we can write for a unit vector ax is going to be cos pi of into unit vector a rho minus sine pi unit vector a pi. Then for ay is going to be sine pi a rho plus cos a pi. Then for az is going to be az only. This is in terms of your Cartesian. In terms of your cylindrical, a rho is going to be cos pi ax plus, just a sign will be changing here, plus sine pi ay. Then a pi is going to be minus sine pi ax plus cos pi ay. Az is going to be equals to az only. This is what the equation you will be getting in terms of our unit vectors. Then magnitude of all the unit vectors is always 1, because square root of the magnitude if I find, I'll be getting as 1 only. Sin square pi plus cos square pi is going to be 1 only. Then let us consider right angle triangle of OAB here for this in the xy plane, such that our RB directed from O to B, directed from O to B, this is directed from O to B, this is RB is in the positive x direction, RA from O to A it is in positive rho direction in this direction, that is OA. Then and RAB is direct from A to B, this RAB, then is in the negative direction, both in a positive direction, RB and RA. Then our RAB is in the negative direction. Let RB magnitude of this is going to be 1. Therefore, RB is nearly equals to AX, because both magnitude, if in terms of I'm going to be, both are going to be equal to 1. For that reason, based on that, we can write that. In the triangle OAB, cos pi, we can write off OA divided by OB, cos pi, cos of pi, OA divided by OB, the basic what will same thing here. Then RA divided by RB I can write in terms of a magnitude. Then RA is equals to of this if I want, I can write as RB mod of RB cos pi, that is nothing but RB is going to be equals to, observe here, it is almost all particularly if I am going to RB into 1, our AX is going to be absolutely 1 only, near to like that. Then I can write instead of RB I can write as AX mod of AX cos pi, that is nothing but mod of AX is always 1, so therefore you will be getting as cos pi only. But for the same angle, in terms of this is in terms of cos we wrote, and also in terms of sine is going to be opposite to adjacent. AB divided by OB is going to be RAB divided by RB. Again RAB I want, that is going to be RB sin pi, that is equals to RB is of AX, already we had taken, into sin pi. Again you will be getting as AX is going to be 1 and sin pi you will be getting off. Then hence based on these we can write as RA is going to be cos pi A rho, then RAB is going to be minus sin pi A pi, then RB is going to be AX, that is equals to RA plus RAB, that is nothing but cos A rho, adding of this, minus sin pi A pi. For the same thing for the triangle OCD, in the same fashion how we derive, we can write directly, it's no derivation. RD is going to be AY for the AY component. Then RD is equals to AY, that is equals to RC plus RCD, that is equals to sin pi A rho plus cos pi A pi, you will be getting off. Just remember these equations and this equation, that will be more than enough. Then it should be noted that right angle triangle is formed by drawing a perpendicular from the head of AY bar to the line joining the origin and point C. Based on this, here it is telling right OC perpendicular line for the AY, perpendicular line for the OC. In terms of arrow bar, if you draw a direct line. Also note from the two figures of here, in general way we are telling that RA is not going to be equals to RC. Therefore, the two magnitudes would be equals to equal for the magnitude of RA and RC is going to be equal when it is going to be equal, when it is of pi is should be 45 degrees. This is one small point. Next, relationship between our vectors AXYZ with A rho pi, Z is going to be A is equals to AX cos pi plus AY sin pi of A rho plus minus AX sin pi plus AY cos pi A pi plus AZ is going to, and unit vector AZ. These equations based on here what we are telling, cos pi, sin pi, sin minus sin pi, cos pi. Based on this, those equations we are writing a unit vector here. Then or else I can write as A rho is going to be AX cos pi plus AY sin pi. AX cos pi AY sin pi. Based on this unit vector equation only we are writing the vector equations here. Then A pi is going to be minus AX sin pi plus AY cos pi, and AZ is going to be equals to AZ only. This is in our cylindrical in terms of a Cartesian system. In terms of a matrix, if you are able to remember this equation, you can write, or else you can, in terms of a matrix form also you can write. That is A rho A pi AZ is going to be equals to cos pi sin pi 0, then minus sin pi cos pi. Here it will be 0. We will be getting only of Z part. Therefore 0 0. At last we will be getting 1 only. Cos pi, this cos pi here, then sin pi here. Z term is 0 here, for that reason 0. Here minus sin pi cos pi, Z term is 0. Here sin and cos is AX AY components are not there, for that reason AZ is going to be equals to 1 here. Remaining part are 0. Then AX AY AZ. Take this as equation 2. Then inverse of this is going to be getting, will be getting for our cylindrical coordinate system. If I want Cartesian, I can take here as AX AY AZ. Observe here, cos pi sin pi, same thing, minus sin pi cos pi, remaining as it is A rho A pi and AZ. If I solve for this, I'll be getting as, or else AX AY AZ is going to be cos pi. Sign will change here, minus sin pi 0 sin pi cos pi 0 0 0 1, and it is a rho, a pi and az. In terms of a dot product equation, that is going to be ax, ay, az is going to be ax, a rho, you can remember like this, ax, y, z, a rho fully, then ax, ay, az, a pi, then ax, ay, az, and then az. Just to remember here, in terms of a dot product, we can write like this, into a rho, a pi, az. These equations in terms of matrix you have to remember, and when the question it is asked to write the relationship between any of the coordinate system, first you have to write the first equation, then draw this diagram, remember the differential unit vector, then these equations, a small derivation, and these two equations are important. After that you can write the equation of this, then equation 2, this equation, and about the dot product equation. These all equations are very important. Then equation 1, what we have taken, where is our equation 1? This is equation 1 is in terms of a point to point transformation. 2, 3 equation, that is the matrix forms, are for vector to vector transformation. Very important question. Today only, once you practice the relationship between your Cartesian and cylindrical. Next, we'll go with the spherical coordinate system. In a spherical coordinate system, the varying factors are r, theta, phi. In our Cartesian is of what? X, y, z, and cylindrical rho, pi, and z. In a spherical system, it is of r, theta, pi. You have to remember this. Based on the variables only, you have to tell which coordinate system it is of. In spherical coordinate system is most appropriate when it is dealing with the problems having degree of spherical symmetry. When we are having a degree of spherical symmetry in terms of your motor structure, in any of the spherical materials, how it is going to be using in terms of a magnetic field, how it is going to be generating, how you are going to give your supply, based on how it is going to be, how much the magnetic field is going to be generating for the spherical materials. For those, you can apply our spherical coordinate system. Then a point P can be represented as r, theta, pi. How it is here, it is shown. Observe here. This is our spherical coordinate system. The P is located here. For this is our pi, same as our cylindrical coordinate system. This is your x, y, z, three-dimensional way. Then this is the distance what we are taking from origin towards P. It is here, it is taken as r, radius. Then our unit vector is going to be varying. In the radius direction, it's going to be, that is taken as AR. Then for pi is in this direction. Then theta in this direction. A theta, A pi, and AR. This is what our spherical coordinating system. Then from the figure, R is defined as the distance from the origin to the P. R is a radius of the sphere centered at the origin and passing through the T. Then theta is called as the angle between the z axis and the position vector. Colatitude we are telling. Then our pi is measured from the x axis, and it is of the same what we learnt in the cylindrical, that is azimuthal angle only. The ranges of the variables, r is going to vary from 0 to infinity because r will be positive values. Then theta is from 0 to pi and pi is from 0 to 2 pi. When pi changes from 0 to 2 pi, theta needs to be varied from 0 to pi. What it is taken, here it is written, that's it. Only to map the spherical value within the distance r from the origin. To get the spherical value, we are going to take the theta and pi from theta as 0 to pi and pi as 0 to 2 pi. Then vector form for the spherical coordinate system is going to be AR, A theta, A pi, or else AR with the unit vector AR plus A theta, unit vector A theta, then plus A pi, unit vector A pi. Where our AR, A theta and A pi are small in terms of small letters are going to be unit vectors along x theta pi direction. The magnitude is going to be for a vector A, magnitude of vector A is going to be AR square plus A theta square plus A pi square to the whole 1 by 2 RL square root of, you can write it out. Any of the one method, it will be enough. Then unit vectors AR, A theta and A pi are mutually orthogonal. AR being directed along the radius, of course R is representing the radius only, or in the direction of the increasing AR, where it is increasing in that direction our AR is going to be representing. Then A theta in the direction of increasing theta RS, and our A pi in the direction of increasing pi. Therefore, in terms of dot products, when they are similar, that is AR dot AR is equals to A theta dot A theta, A pi dot of A pi is going to be equals to 1. When it is of two different variables of unit vectors, it will be value is going to be 0 only. Then in terms of cross product, AR cross with A theta, you will be getting as a, which one is not there in the unit vectors, then you have to take that is here it's going to be A pi. Based on our circular permutation, we can write the equations. Then A theta, A pi is going to be cross with A pi is going to be AR, then A pi cross with AR is going to be A theta. Then the relationship between our Cartesian coordinate system with the spherical coordinate system is going to be a figure representing here. Observe, in the cylindrical coordinate system we just represented, observe here, just represented a point, and we just extra things what we want, the rho we want and pi we want, z will be there only. For that reason, in the z-axis we didn't written anything, but when we are going for a spherical coordinate system, observe here, we want x, y and also in terms of a z, because all the variables are different when compared with the Cartesian to the spherical. Here is our pi and this is your theta and this is your rho. This is in a spherical. Then this distance is going to be y is equals to rho sin pi. Then this is your x is equals to rho cos pi. Here the point, it is in terms of Cartesian, cylindrical and also in terms of your spherical. Then the distance of this is going to be taken as rho is going to be r sin theta, and this distance is taken as z is equals to r cos theta. Here sin in terms of sin, here it is in terms of cos, here also sin, here in terms of your cos. Then relationship between all the three, that is x, y, z, Cartesian, cylindrical and also in terms of spherical. Here it is given as rho is going to be, already we taken, that is x square plus y square. Here the r is going to be, it is varying in all the three factors for the spherical. For that reason, x square plus y square plus z square, and theta is going to be tan inverse of square root of x square plus y square divided by z theta, and pi is going to be as usual what we taken previously, the same thing here, that is going to be tan inverse of y by z, or else in terms of x is going to be r sin theta cos pi, and y is going to be r sin theta sin pi, then z is going to be r cos theta. Z in terms of r cos theta, y in terms of r sin theta, then sin pi, z is going to be r cos theta. Then since x is equals to rho cos pi, y is equals to rho sin pi, and again rho is going to be r sin theta, above equations what we take xyz in terms of r theta pi, then and r theta pi in terms of xyz, it's of a point to point transformation. What the equation we taken, it is in terms of a point to point. Next, the unit vectors ax, ay, az and a rho, a pi, a theta, a pi are related as it is as shown in figure. That is ax is going to be sin pi cos pi ar, then cos plus cos theta cos pi a theta bar minus sin pi a pi. Then ay is going to be sin theta sin pi ar plus cos theta sin pi a theta plus cos pi a pi. Then az is going to be cos theta ar minus sin theta a theta, or else this equation I can write as ar is going to be sin pi sin theta cos pi ax plus sin theta sin pi ay plus cos theta az. Then a theta is going to be cos theta cos pi ax plus cos theta sin pi ay minus sin theta az. Then a pi is going to be minus sin pi ax plus cos pi ay. These are the equations you will be getting of in terms of a unit vectors. Then component of a vectors, vector a is going to be xyz, ax, ay, az in terms of Cartesian, in terms of our spherical ar, a theta, a pi. This equation is going to be a is equals to ax sin theta cos pi plus ay sin theta sin pi plus az cos theta. It is of for the unit vector ar. Then for a theta it's going to be ax cos theta cos pi plus ay cos theta sin pi minus az sin theta, then plus minus ax minus of ax sin pi plus ay cos pi into a pi, or else I can write as ar is going to be the whole parameters you have to write here. Ax sin pi sin theta cos pi plus ay sin theta sin pi plus az cos theta. Then a theta is going to be ax cos theta cos pi plus ay cos theta sin pi minus az sin theta. Then a pi is going to be minus ax sin pi plus ay cos pi. In terms of a matrix form, I can write as ar, a theta, a pi, this term here, sin theta cos pi, then sin theta sin pi, then here it is a cos theta, then cos theta cos pi, then cos theta sin pi minus sin theta, then minus sin pi cos pi, and z equation is going to be 0 only. Then it is of ax, ay, az. Then inverse of this is going to be from spherical to Cartesian. Then ax, ay, az is going to be sin cos pi cos theta cos pi minus sin pi sin theta sin pi cos theta sin pi cos pi cos theta minus sin theta of 0. Here it is going to be ar, a theta, a pi. In terms of a dot product, here observe here ar, a theta, a pi is going to be ar, a theta, a pi. Here it is going to be ax ax, then here ar, a theta, a pi, here it is going to be ay, and here az. You have to remember like that, then it will be easy to remember how to write the equation. Then ax, ay, az. Then distance between the 2 points, usually necessary in the electromagnetic theory. Then the distance between the 2 points vectors, that is r1 and r2, is going to be, d is going to be, already we come across this, then r2 minus r1 bar, mod of r2 minus r1 is going to be, how I can write in terms of a Cartesian, x2 minus x1 whole square plus y2 minus y1 square plus z2 minus z1 square in terms of a Cartesian. In terms of a cylindrical, you have to remember as d square is going to be equals to rho 2 square plus rho 1 square minus 2 rho 1 rho 2 cos pi 2 minus pi 1 plus z2 minus z1 square. Then d square is going to be r2 square plus r1 square minus 2 r1 r2 cos theta 2 cos theta 1 minus 2 times r1 r2 sin theta 2 sin theta 1 cos pi 2 minus pi 1 in terms of your spherical. These equations you have to remember when solving the problems. It will be helping for us. Then the unit vector transformation for cylindrical and spherical coordinate system, this is how it is varying. Here a theta is varying in this direction, minus of a theta, then a rho in this direction, then ar, and this is in terms of az. How in terms of a unit vector, how it is varying. This is your rho, and here it is z. This is the angle of this, that is theta. This is all about our coordinate system. First we learnt our Cartesian, then cylindrical, and then spherical coordinating system. Okay, we'll stop here. We'll continue in the next class.